Guys, it's great to be here tonight. Appreciate y'all coming out. Hopefully this will be entertaining and interesting and educational as well. Tonight I'm going to talk about, actually kind of give you a little history of low power wide area networks and how we've come to this place that we are now. Technology is moving very rapidly. We're in exponential time, so it's exciting because every year, every 2 years, things are changing dramatically. And I think we're at one of those inflection points right now when new things are about to happen that are going to change the world in ways we can't even imagine right now. So I'm going to talk about the machine-to-machine and how it's evolved into the Internet of Things, and about what the three components are that I think that make up the Internet of Things. And then we'll talk about low-power WANs, all the different players that I've been following for the last 3.5 years, and then we'll get into talk a bit more about them. I want to thanks to Google. The Internet is awesome. These people have provided all kinds of good information for my presentation tonight, so I want to give them credit. So, actually, the first machine-to-machine system was, a lot of people consider to be the telegraph back in the 1840s. And since then, we've developed machine-to-machine communication capabilities, and we call it by different names: telemetry, SCADA, industrial automation, telematics, sensor, and whatnot. And we've used various technologies: the wireline, the microwave, private radio, Wi-Fi, satellite, cellular. I actually sold the first machine-to-machine system in Houston for Motorola back many years ago. We used private radio network, mechanical relays for the end devices, and mainframe on the back end. So very rudimentary, but the basic concepts are always still the same. Just we keep adding technology in each of those components to make increase power and decrease the cost. So what's going to happen here shortly? Many analysts are predicting we're going to be at 50 billion devices here soon. Some people say 4 years, some people say it's 10 years. But the point is, we're going to have a tremendous number of devices that we're going to need to connect to the internet and be able to monitor, control, and analyze. So the three components I consider that make up the Internet of Things are the devices, the sensors, the things, and the endpoints that are out there in the world. And then the connectivity, whatever that technology is. And I'm a wireless guy, so this is what I've been watching and learning about all along for many years now. Then the back end, that's a complex and rich environment with all the different software, the networks of their own, and the analytic tools and the storage, all the different components that make up the back end. So my focus tonight, though, is going to be on the wireless part of the network. And as I said before, we've used cellular in it. 2G was a pretty good way to do machine-to-machine communications, but the 2G networks are being taken down. AT&T turns their network off January 1 of this next year. Everybody follows suit then at some point. What's happening, they're stealing or refarming those frequencies so they can put 5G into the networks out there. And so a lot of there's 30 million machine-to-machine devices on a cellular 2G network, and those guys are going to be left high and dry here soon. So we need to find alternatives, and I think you'll be impressed with one that we'll talk about in a minute. Then of course Wi-Fi and other short-range technologies will have its place, and Zigbee and Bluetooth and whatnot have their different advantages and can control and monitor things in local environments, but you really need to have a long reach and be able to get into rural areas as well, and it doesn't fit the bill there. You can cobble together a management system for them, but you still can't get out very far with any of the access points. And then there's private radio and microwave, and then you've got satellite. Private radio is not always ubiquitous, and satellite is very expensive. So, the low-power WAN guys. Now, there's a number of people that are playing in this space, and you've probably heard about Sigfox and LoRa, and maybe the weightless SIG group, the special interest group. They've really done a great job at marketing and getting people aware that there's an alternative to cellular. And we're going to go into a little more depth on each of those guys in a minute. But the point here with this slide is that there's going to be a place for short-range communications, the Bluetooth and Wi-Fi capabilities, and then there will be places for cellular. But the majority, and some people say it's 60%, some people say it's 80%, so this is just kind of good general representation. Low-power WANs will be the connectivity of choice for many of the connections that we'll need to make in the future. So what they found when they looked at the use cases for the Internet of Things, that many 86% of the applications out there are only going to need 3 megabytes or less per month. And low-power WANs are a great fit for that kind of requirement. Now, the definition of low-power WANs you have, they need to transmit low power because they're typically on unlicensed frequencies. They don't have to be. The cellular guys are going to come out with their own version of low power WANs, but most of the time Sigfox, LoRa, Weightless, and Ingenu are going to be on unlicensed frequencies. And so you have to be within certain limits to be on those freaks. And it needs to be long range, but it needs to be low power consumption, power consumption, so the batteries will last. They need to last at least 5 years, and most people are saying they want the batteries to last at least 10 years. So the other thing that really needs to happen is to create an infrastructure that's low cost. And the cellular guys have got their hands full. It's going to be a challenge because they have to pay billions of dollars for their frequencies, and then they have to install and maintain this infrastructure out there. So they want the best bang for their buck and get the best return on investment. So they're going to be focused on the smartphones and the high-speed data communications. And I'll get into that more in a minute. So they're going to have trouble creating low-cost systems and low-cost access that we can use to create solutions. And then the system needs to be scalable. If we're going to 50 billion devices here in the next 5 to 10 years, there's going to be a need for the ability to put in a system and then just keep growing and adding connections to it. So that's going to be a key component. Now there's two types of mobility in this kind of arrangement. One is where you put an endpoint in place, but then you move it. You need to move it to a different location in the city or even to a different country. And you want that device to be able to rescan and reconnect to the network. The other type of mobility is truly tracking something that's moving. So a vehicle or an asset, an intermodal container or something like that, you may be wanting to watch as it goes point to point. So depends on your network whether it can do that or not. Those are some of the requirements that we're going to need. And it's going to need to be reliable. It doesn't necessarily have to be high speed. It doesn't need to necessarily be real time, but it needs to be reliable. So we know that information is coming in when it's supposed to be coming in. So these are the players in the low power WAN area that I've been watching for the last 3.5 years. I got started 3.5 years ago. I was studying up on protocols in the wireless world, and I've happened across this thing about Weightless special interest group out of the UK. And they had created a protocol that was going to use the TV white space and coexist with broadcast people and connect machine devices. They saw the future coming and the need for a low power WAN capability. And so I mentioned to my friend that happens to be the director of the IIOT up there, said, if the guys would like me to come, I'd be glad to come and talk to them. Well, 2 days later I got a call and they said, we'd like to take up on your offer. And I said, how many months out do I have to prepare? He said, 8 days. So I had no proposal or real presentation put together. So I reached out to the professor in the UK that ran this SIG for the Weightless and asked him, can you help me? He said, sure. He sent me his slides. He had his marketing team send me slides. I put together a presentation that put me on the path of analyzing and keeping up with the low power WAN guys. And every 6 months, the IIOT up there invites me back and I give them an update on what's going on. So what I realized, what happened to Weightless W now it's called, but for the TV white space, it got put on the shelf because the UK and the US are the only two countries that have approved the use of TV white space to be shared with the broadcasters. And so if it's not going to be a world capability, then there's not economies of scale, so they put that on the shelf. So they came out with Weightless N. I'll talk more about that in a moment. So Sigfox and LoRa recognize that there's a need for low power WAN communications, and they realized that the 915 is a center frequency. 902 to 928 in the United States is unlicensed frequencies that could be used for this kind of thing. And over in Europe and many other places, then 868 in that range, sub-gigahertz is the idea, could be used for this kind of communications. The problem is they rushed their technology real quick and then they started marketing real fast. So I'll talk about that more in a moment. With the Weightless W put on the shelf, then they looked around, what can we do? A company called Enwave had a similar technology to Sigfox and LoRa, narrow band kind of technology in the sub-gigahertz ISM bands. And so Weightless adopted their IP, or accepted their IP, and put it into the protocol, into the standard that they came out with. So that's out there as well. Then here recently, they've come out with a new standard called Weightless P for performance, and I haven't seen all the details on that, but it looks promising. I think that it has a good chance of being one to keep an eye on that might have opportunities. The problem with the Weightless SIG and the Weightless approach is they don't have a champion. They don't have a large company as a cornerstone to build their marketing and point to, and have somebody moving the adoption forward. So we'll have to wait and see. There's rumors that there might be some sort of announcement here in the near future. So keep up with that. The gorilla in the room, though, are the cellular guys. So they're going to come out with narrowband IoT, NB-IoT. It's in 3GPP, their standards group right now. If they adopt it this month, which they're working hard against the deadline. If they adopt it, then they will have an approach to low power WANs that will give them a chance to get market share here probably in the next 2 to 5 years. It depends on who you talk to as to how long it's going to take for this standard to get adopted, to get tested, to get deployed throughout the world. So they're under the gun. The problem that cellular faces, there's several of them, but one of the key problems is it's so fragmented. You would think a standards group would cause things to come together. That's not what's happening there. Their focus is on smartphones. 5G, high-speed data communications is where they're going. That's why they're taking away the frequencies of the 2G networks that are good for machines. So that's the real focus. But they know that they need to come up with something for machines. But they have 4 different protocols and standards that they're looking at right now. They've got LTE-M for machine. They've got extended coverage GSM. They've got 5G IoT that they're talking about. And then they've got NB-IoT. So that's fragmentation at that level. Then they've got 40 frequency bands that they work with around the world, all these different carriers. And there's over 800 carriers in the world. And if you produce a product, a device that goes on their network, you have to get it certified with each carrier that you're going to put it into that country. So they've got real issues to create economies of scale and an ecosystem to support that kind of fractured arrangement. But don't count them out because they're very resourceful, they've got a lot of money, and there's a lot of people that want to make that happen. So time is against them is their biggest problem. And then there's Ingenu. So I've been following the analysts talking about on-ramp communications, which was started back in 2008, the forerunner to what is called Ingenu now. And the analysts said on-ramp is only in the utility and oil and gas industry. It looks like that's all they're going to stay in that niche area. Well, in January, I read things had changed. And what I read was that a guy named John Horn, who has been in the business 12 years, he started with T-Mobile in their machine-to-machine group over there, built them up, and about 4 years ago left and created Rayco Wireless and built them up and sold them about 18 months ago to Core Wireless. He then had been watching OnRamp. He went to the board of directors of OnRamp. Now he's sold his Rayco Wireless company, so he's got time and money. And so he goes to the board and he says, guys, you're the best kept secret. He's been watching these guys and studying them. You're the best kept secret in the industry. Let me help you. The board of directors said, great, what do you want to do? He said, I want to do 2 things. I want to change the name and rebrand the company. So he changed it to Ingenu. Everybody goes, what the hell is Ingenu? So, and the next thing he says, I want you to commit to putting in, they've already put in 38 private networks around the world since 2008. He says, I want you to take that and put in public networks in 30 US cities by the end of 2016. The board says, okay, we got some money, let's do it. And so that's what I read in January, and I went, holy cow, there's more here than even the analysts recognize. To put that kind of money and commitment out there, there's something else going on. So I started studying their technology much deeper. And I'll give you some links here in a minute. If you want to, you can go out and start looking at these things. Fascinating what they've done over the 8 years and 300 man years or person years of development that they put into this to take their theories, actually put it in the real world and enhance them and solve problems and take different tacks when the theory didn't work out in the real world. Now they have 8 years and 300 person years advantage, head start on everybody else. So he's putting in the 30 cities. I read about this in January, and by the time Barcelona came along, the end of February, the Mobile World Congress, representatives of 25 countries around the world had come to Ingenu at this point and signed lease agreements to put in this technology in their countries. That was in the end of February. Now we're up to 50 countries and we're talking to a lot more. So what's going to happen between now and the end of 2017, we'll have over 100 cities in the United States with a public network. Austin's one of the first ones to get it. And over 50 countries will be up and working in the next 18 to 24 months. So, exciting things are happening there. So, one of the things about the sub-gigahertz bands that Ingenu and N-Wave and OnRamp are using, Ingenu, Sigfox, LoRa, I get out of it. Sigfox, LoRa, and N-Wave are using are the 915, 868, also 315 and 433. But those are not in every country in the world. There's a lot of places where there are no frequencies, no ISM bands, no free sub-gigahertz frequencies to use. But 2.4 gigahertz, the Wi-Fi frequencies we know, 80 megahertz worth of frequency of spectrum, is in every country in the world. There's little differences in the way the rules are applied, but the basic thing is that our technology fits in that and goes in every one of the countries in the world. So, OnRamp, I say, started in 2008. This actually came out of, there were engineers that came out of Qualcomm. So if you know about Qualcomm, they actually worked with the federal government back during the Cold War, and they created clandestine communications and hid the communications in the noise floor. The Soviets couldn't figure out where our communications, where we were transmitting, and they look and look. So they do an incredible amount of signal processing to hide it and spread it out. This is the spread spectrum technology that they created, and put it in the noise floor, and then they pull it and extract it at the other end. These engineers that came out of Qualcomm continued on and came out with CDMA and have been working with the cellular industry now all this time to create high-speed data communications. These OnRamp guys that came out of Qualcomm said, we see the future in machine-to-machine. We need to create a communications protocol that's dedicated to machines. And so they took a different path. They do a lot of processing gain to the signal when they spread it out, and they do all kinds of encoding with this signal that they put into the noise floor. So by taking a different tact, they've come up with a very unique approach to doing low power WANs. They started there in San Diego. Qualcomm's there, so these guys came out of there. San Diego Gas Electric's right in their back door, and they happened to be had a relationship, and the San Diego Gas Electric said, sure, we'll be glad to help you guys take your theories and your ideas and apply it in the real world to a situation we need to monitor our distribution grid, our network. Yes, sir?
What's their target for range?
Well, it can be, depending on the environment, like any radio network, it depends on, are you in an urban environment or a highly dense foliage area? So you look at 2 miles, 8 miles, and 10 miles. It can go further if you're out in the boondocks. So what they found in San Diego Gas Electric, who was their first customer, is that they had that 300 man-years of development for the first 3 or 4 years that they got to try things out, change things, and improve their communications. And they also got beat on, improve your reliability and your security. So those two things then allowed them to create a very powerful protocol. Yes, sir?
Yeah, but at 2.4 you have a penetration. So you're talking about a wide open field, I take it.
So
you're up high and you can get line of sight.
Our antennas are on 150 to 200 foot towers typically. As we build the networks out to start with, and we're doing coverage area, outside coverage with a little bit of penetration into the rooms. Our radio signal is 175 dB of radio link, and so link budget. So you can apply that and use that for range, or as you densify the network, that 175 gets used to penetrate into basements, into vaults, and to parking garages, that sort of thing. Now, if all things were equal, and you looked at a sub-gigahertz, a 900 or 868 megahertz frequency, and you compare that to 2.4, you're down dB. We're already 9 dB in deficit in comparison to those two signals, two ranges. But what happens is, at 2.4, we have high sensitivity receivers. So in our application or access points, our receiver sensitivity is negative 145, an incredible amount of receiver sensitivity. Our access points are 133. You combine that with the fact that we're at 2.4, your quarter wave is very small, so 1 inch and you're out of a null. We use diversity antennas. So we put 2 antennas in every one of the devices that we put out there. Now we've made up for that 9 dB difference. The two are now equal. Then you add on top of that the processing game and the special our calculations that they do to manage and manipulate the signal, now we're able to do things that people didn't believe was possible. So we now have 38 networks in the whole in the world in 5 continents that have been working over the last 8 years, that we've installed over the last 8 years. And now we're going to be putting in 30 more. Our Dallas network came up last month. This Austin network is up now, and we'll be bringing up, well, I'll show you the list here in a second. So security reliability for San Diego Gas and Electric was very important. They made us rise that line level, so now we're FIPS and NIST certified in our capabilities. And the 300 man years or person years is just a huge advantage over anybody else. So, a couple of things that they're doing with the signal that they're transmitting. So they have highly adaptive encoding. They're always broadcasting a channel. The remote device is looking at the channel. We're doing TDD, time division domain, on one frequency. So whatever comes into us, that channel is going to be the same, reciprocity. So we recognize and we analyze and figure out what coding scheme they use, and it changes as necessary to reach into a location. And we transmit back with an appropriate coding scheme, back up to that side, an appropriate power. Now the second thing here, dynamic, tightly controlled dynamic power control. This is one of the key things that differentiates us from Sigfox, LoRa, and N-Wave. We, at the endpoint, analyze the signal coming in, and then we send back the appropriate power. When you've got access points out there, we'll install the network for outside coverage to start with, and we'll densify it. If you run out of capacity, then you can stick in another access point in the middle of all of these other ones. The access, the nodes, the endpoints, will rescan, see that access point, the closest one, and tune its power down. When you do that, you don't have, when you don't do the power down, you get all this mess because everybody's still transmitting full power, worst case, and you're getting into all these other transmitters that are around you. When you tune your power down, you essentially shrink your cell site down so that they don't overlap as much as they would in this kind of arrangement. So that's important because as we need to go to billions of devices, we're going to be able to scale the network and keep adding access points. And not only does that increase your capacity, but you've got that 175 dB link budget that you're able to use now. Instead of just for coverage, you're able to use it to penetrate down into buildings. What San Diego Gas and Electric has found is that they have a lot of underground grid and underground equipment. And so they had us, and it takes an engineer, you need to look at your network and see where you need to do this. But what they found is they often sometimes had equipment down a hole, down the tunnel. They don't have to put an access point right in the top of the hole. They just need to have it close enough so that there's enough link budget to be able to get the signal through any cracks and whatnot and get down into that equipment. So they're very pleased with it. They're able to get coverage with all of their underground equipment as well as all this stuff above ground. And they cover 4,100 square miles of area. So, security, our protocol is called random phase multiple access. It's a spread spectrum, so it's direct sequence spread spectrum, differential, binary phase shift keying on the baseband. Now, interesting is that they optimize the system for upload, because there's going to be lots and lots of devices sending small messages, but there'll be lots of them. So they make sure that there's plenty of capacity on the upload side, and then they have enough for the download side. They can even download upgrades to the firmware in your devices. That's how powerful and robust this protocol is. And by having they're on a 1 megahertz channel. I'll talk about that more in a moment, but they've got a full megahertz of frequency that they're spread out over. They're able to give a decent amount of data back down. Now these, we're not set up for high speed, so you can't do Netflix and you can't do video and that kind of thing. What you can do though is keep up with meters and with objects in the field. As long as you don't go over 3 megabytes per month, then that fits within our data model of what we are managing and building our network to support. And typical, we can do 50 square miles to 300 square miles. If you do 300 square miles, that figures 10-mile radius, approximately. So it depends on the environment. Radio depends on how much stuff is in the way, basically.
Yeah.
Yes, sir.
Do you know how far underground?
I don't know the distances they were talking about. They were down the hole and down the tunnel, and so it's not right there by the hole. But I haven't seen it. I haven't seen the details on that. But it's a matter of figuring out how close you need to be to have enough signal to get down there, and then have margin to get there. It's an engineering exercise. So we got 38 networks in the world. I talked about John Horn came on board and changed the name and committed them to 30 networks in the United States, changed the name. Exciting times. So I went to Barcelona and 25 countries then, and what happened to him, when all these entities, all these representatives came to him and they signed contracts, he says, my 5-year plan just went to 5 months. So, I think it's a little exaggeration, but the point is that all this interest by all of these other people outside the United States have given us an opportunity to move much faster. And they're paying us up front for the license to put their networks in. We're always going to, Ingenu is always going to own and manage the US network. We are a cellular company for machines. And we will manage and maintain and build for that network. But outside of here, outside the United States, there'll be other people that will do that. There's a lot of telecom and companies in the telecom world that miss the boat on cellular and wireless. And they want to get in it somehow. And they're recognizing the Internet of Things, particularly a wireless play, will be the way to do it. Some of these guys had already committed, or were about to commit, to Sigfox and LoRa. And when they're technologists, and they already promised their countries that they were going to put in a low-power wide area network. When the technologists looked at the ability of Sigfox and LoRa and witness in to scale, they can't do it. What are we going to do? And they came to us. They looked at our technology and go, holy cow, these guys can scale. They do what they say they can do. They've got 38 private networks in the world. They changed their contracts to us. And that's why we now have 50 countries under license. And we're using that money to help build out the United States, and we're speeding up our deployment process. Almost done. So the 30 cities gone to 100 now, and 50 countries around the world. So the first network we turned up in the whole world was in Dallas, and I got hired because I recognized that Dallas was the first place it was going to turn up. I told the guys, hire me. Come to Dallas, and I'll take you around. And they said, we don't have budget for you. Well, come to Dallas, I'll take you around. I took them to 6 different prospects, and I set up a meetup just like this. I had 90 people. We had to bring in chairs. And a week later, they said, why did you do that? You don't work for us. I want to show you what I can do and my value. They give me a contract the next week. Hopefully, they'll hire me in a couple of months. So the next networks are going to be here shortly. Austin's up now. Houston and San Antonio will be next month. And then we've got Phoenix came up last a week or so ago, and then Riverside is about to turn up as well. And then we go to the third quarter, and then in the fourth quarter of this year. And these are being jostled around because a lot of people are saying, move me up in the schedule. So if we can, we will. But in some cases, we're going to be putting in we're going to lease an access point to them, or several access points if that's what it takes. So that they may have a development group, or they may have a particular situation, a hospital or an area that they need to cover before it's in our schedule. And so we're going to lease it to them, and depending on how many access points there, we'll charge them something, or if there are enough access points, we'll charge them nothing. And then eventually we'll take over and add more access points in that area. It's a matter, just like the cellular guys, they put up an antenna and they covered an area with that one antenna to mobile devices in the cars. And then McCaw came along and said, I'm going to build it for the handhelds. And so they put up many other cell sites and kept densifying and expanding the networks. We'll do the same thing here. We'll be adding more access points as needed. David, do you have a question?
Are those cities connected to each other, or is each one in isolation?
It's in isolation right now, and that's a good point. Cellular was the same way. We had all these pockets. So at some point, we're going to want to connect them and put the access on the roads. It takes time and money, and that's what we're working against right now. Yeah,
how many access points here in Austin?
8 access points for outside coverage. So thank you for asking. There we go. So this is the Austin. So it goes up past Georgetown, out to the Lake Travis, and then this is it Buda or Kyle? Which one's south?
Buda.
Buda?
Buda.
Excuse me. I should know that. My son went to San Marcos to Texas State, so but San Marcos is what I remember. So Buda is there for that. But San Antonio comes up, and I'll show you that in a moment. And then it says Taylor up there. I don't think it quite makes it to Elgin. Did I say that one right?
Yeah.
Okay, all right. So, but that's the coverage for outdoor right now for the Austin network. So this is San Antonio. So it goes up to San Marcos. So they just about connect. And we're working with some guys. Never mind. So anyway, we'll eventually connect all that in there as well and dissipate it. So Gonzales and down. There's actually, Delaware has a private network south in the Eagle Ford Shale, which is south of here. And that goes from Laredo, south of San Antonio, Laredo, up through College Station to north of Houston. And their private network is going to be turned into a public network. Kind of. Anybody that's not in oil and gas can use it. If you're in oil and gas, you're out of luck. So I don't know how it works, but anyway. But for the cities where we're putting our network in, anybody can do that. Yes?
So, who are the early adopters of this in Austin or Dallas?
So what we're putting in there, we're making a commitment, but we're only the connectivity part. We need people like you guys. We need device people, sensor guys, people that know how the endpoints need to do, what they need to function, what they need to monitor and be able to control. We need solution application guys on the back end to create the applications that will monitor and control and analyze these devices in the field. And then we need systems integrators to take all of this and pull it together. I'm just the connectivity part, and so we need your help to do this. So what's happening right now, we've got a lot of people looking at using us. It's a chicken and egg thing. So everybody kept saying, well, put your device, what device do you have, and I'll build a network for you. And they go, no, if you don't have a network, I'm not going to build anything for you. So, okay, we're going to commit to putting a network in. So now we got people coming to us and going, I've got this idea, I've got this product and whatnot. So it's time. Now it's beginning to happen. And so there's lots of ideas brewing out there. Now, let me show you real quick and then we'll go to the next question. So that's Dallas. So all of McKinney and Denton and Fort Worth over the edge of Weatherford down to Waxahachie and Mesquite. So, and that's 18 cell sites. With 16 are up and working now. 2 are not working because we've got red-tailed hawks nesting in 2 of our towers. So we can't do that until September. But we're still getting very good coverage. We're a little weak on the west side toward Mesquite for right now. And then, back up. So this is Houston. So all of Conroe, out past Katy, down south of Galveston, and all the Bay Area where the oil refineries and the ship channel is, and then up to about Liberty on the east side. So, was another question?
I'm sure you have a slide on price and cost for end nodes and access, all that. Or do you want to?
Yeah. So, 2 things right now. So so we have what we call a micro node right now. This is what we do, a lot of manipulation of the process of the signal, and so we use an ASIC. Standard processors wouldn't work when they were looking at this thing. The things they do with mathematically with the signal requires very special chips, and so they created their own ASIC. That was $1 million bet, and they won. They created a working ASIC. So on our interface module, which your devices and sensors connect to create your device, we'll talk to our network. So you've got the ASIC, and then you got the RF module. And that right now is what we call a micro node, micro 2 node, and it's about 2 inches by 1 inch or something like that. And then we're coming out with the nano node, which will be like about an inch to a half inch or so. And we'll have quantities of that next month. If you bought just one, it's $20. When you go to quantities, then it's going to go down from there. In a year's time, we're talking to several large companies about producing the pico node, which would be the size of a quarter. And we want out of that business. We want to give you guys the choice of who to buy from for the devices out there. And so if we give you 3 or 5 different manufacturers who have different price, different feature sets, different configurations, whatever, then you can pick what you need for your particular application. So that's going to be a year out for that new one. The nano node will be out next month, starting to ramp up quantities. For the access to our network with one device is between $1.50 and $1.25 a month per device, right? As long as you don't go over the 3 megabytes data model that we have out there.
So that goes
It'll
up
go
to
down
your
from there with
servers,
quantities.
That goes up to your servers, and then I catch it on the outside like LoRaWAN, or
Yeah,
how do I get the data?
So, access points, I'm sorry, let me start there. The end nodes transmit, many of them out here transmit up to an antenna. That's our access point. I'm a cellular guy, so I keep calling it base station, but basically a receiver. Then that receiver goes backhaul, and it can be any kind of backhaul. Since we're in the network and you don't care, but in some places, if they're remotely out somewhere, we can't easily get to it. We put a cellular SIM chip in it, and we use cellular, aggregate, and then come back with cellular. But oftentimes we put it in fiber or Ethernet or something like that, bring it back. So then it comes back to a gateway, and then the gateway has REST interfaces, so you can access that. Now that'll evolve over time if we need to start pushing stuff out. Right now, it's up to you to just reach in and get the information on the REST.
As it comes out.
As it comes out.
Right.
So it's stored there, and however long it needs to stay there, I think there's 2 days or something like that, it'll sit there and then be flushed. Kind of thing. Yes, sir?
What kind, do you see a concentration of industries? It's sounding a lot like, at least for Texas, oil and gas.
Oh,
And you mentioned earlier another stuff, utilities.
this is what?
You mentioned utilities at
Yeah, so if it's,
what's your concentration? Yeah.
we don't have a true concentration right now, but the Internet of Things, the focus is on something that is less than 3 megabytes per month, and in something that in the past it was too expensive to monitor and control it. So with cellular guys, telematics, cars, anything that was really valuable, it was worth paying the price for those things. So I have to use my outside voice.
Yeah.
So what's happened is that now possibilities become feasible economically that were not feasible before because it was too expensive. When you start getting down to $1 and below for every one of your access points, and your equipment starts getting down to something very inexpensive compared to not only the cost of a cellular modem, but all that certification that you have to go through. And those are $40,000 to $100,000 to get one device certified by one carrier. And you multiply that by 800 if you want to go worldwide, and 40 speakers, all these SKUs. The beauty of our, hey, all right. The beauty of our, oh, it was still on. Okay, so I had better. So the beauty of our approach is that our cost structure, because we don't have to buy billions of dollars worth of frequencies, our base stations are 1/10 the cost of a cellular base station, and we're fronting that cost. So it's not a cost to you guys. We're just advertising it over everybody that we're going to put on the network. The economics become very attractive to start monitoring pets, livestock, any asset that is moving or stored somewhere. The railroad industry loses their cars everywhere. The intermodal containers get put places, and what will happen to them? And so if we can start monitoring those sorts of things, because it's now economically feasible, the mind starts becoming, you start thinking of new ideas and applications that people hadn't thought of before. Hang on. So the thing, that the difference between machine-to-machine communications is that machine communication, machine-to-machine, was about one domain. You were following one item, one industry, you're getting information about one sort of thing. What's happened now, the Internet of Things, is actually many different machine-to-machine domains being packed so that you can analyze the big picture. You can see many different sources of information and start seeing a better view of what's happening in the world and react accordingly. And so, if you've got equipment out there, anything that is mechanical, that wears out over time, you can start putting many of these pieces of equipment, the oil industry and the heating and ventilation companies and all of your home appliances and whatnot are candidates for putting in this monitoring control system. You can keep up then periodically with the status of that equipment. If a bearing is starting to heat up or vibrate or some noise or something that your sensor is picking up, you can start collecting this data, and over time you start seeing the trends of, when it starts doing this, I need to send somebody out there. SAP, I was blown away. I talked to them yesterday, and they have S4 HANA. If you haven't seen it, It is their simplified fourth generation of their ERP system. It is very powerful now because it's the core of many companies and runs their companies. And with this S/4HANA, it's simplified and easy. They're going to be able to do analysis of what's going on and automatically respond and send people out to fix things, people out to look on, take care of things that are out there, instead of getting the data and having to analyze it and people involved. So it's that kind of thing that's going to happen here in the future. Many more of our analysis and reactions are going to be automated for us. Good or bad, it's going to happen. So it gives us opportunities to be able to start thinking outside the box or thinking in ways that we've not thought of in the past because it was too expensive to go that route. So I'm pretty much, I can go into more detail. I'm glad to talk to you afterwards. I don't want to hog the floor. Graeme is going to come talk. He's one of our ecosystem partners, and he's got some incredible technology that's going to help with legacy stuff. So a lot of stuff is out there in the world that never was designed to talk to the internet. These guys can do it now and do it safely and securely. So with that, I'll take a couple more questions, then I'll turn it over to Graeme.
When Dave asked about when you were showing the cities and everything and saying, are they interconnected or something like that, I'm not sure what he meant, but everything comes back to a REST interface that's available on the internet, right? So I can deploy in a market, and I can deploy in Phoenix, I can deploy in Dallas, I can deploy in Austin and San Antonio, my application, because I have access to your market through a REST interface through the internet, right?
Correct. I'm glad you pointed that out. I interpreted that meaning that we would
geographically continue.
Exactly. Yeah, on the roads, and we're not doing that yet. These are islands of infrastructure. But yeah, on the back end, virtually, you can connect all of those places in. The same application can be put every U.S. city, every country around the world, which opens up opportunities for us here in Texas to create things that we can take to all these new networks as they get turned up. So,
Is there any peer-to-peer communication between the nodes?
No, everything goes back to the access point and then is responded. Now, if you need a repeater, you can do that. So your access point could talk to a node. The node is tied to another node which transmits down further on a different frequency if you want to do that, and then back, that sort of thing. So I didn't show you this. This is fun. I want to show you this one, and then I'll quit. These are all detailed things, but so in my slide presentation, I'll make this available too. I can give it to you, right? And put it out there on the
Yes.
and it'll also be on my LinkedIn profile tomorrow. So yeah, can y'all see that? Okay. So these are the Wi-Fi frequencies: 1, 6, and 11. Down here, we split up our channels into 1 megahertz wide with 1 megahertz guard channel. So there's 80 megahertz to work with. So we have 40 channels. So channel 1 down here, San Diego Gas and Electric monitors and covers their whole 4,100 square miles with this one channel, because we don't worry about collisions. We can handle up to 1,000. In fact, it gracefully declines after that. But we can handle up to about 1,000 or 1,200 simultaneous transmissions, because they actually are slightly offset from each other, and our ASIC is able to demodulate all of those signals coming at the same time. So we're able to reuse this frequency in every one of our access points. So they use one channel for all 4,100 square miles. Well, we've got 3 channels between 1 and 6. We've got 3 channels between 6 and 11, and 3 above there that are non-overlapping. Now, we deal with all kinds of interference. Our forward error correction allows us to reconstruct a signal. Even if it gets blasted, half of it's gone. So we don't worry about it. We tend to affect these guys a little bit, so we try to stay out of the key Wi-Fi frequencies as we can. So, yes, David? David. And then you next.
2 Daves in a line.
Yeah, I know. I pointed it.
Could RPMA also be called PDMA, based vision multiple access?
It probably could be. I think my next slide here is the idea, yes, that we're offsetting each one of the transmissions a little bit And these are chips, I think they call them, of time. And we're spreading the signal out over a whole megahertz of channel. We're also doing it in time as well, changing the timing of each of those signals. So we can do, 1,000 or more. If you get above 1,000, it just starts degrading slightly, and your endpoints have to take longer time before they are able to send their information in. David, I guess I'll turn it over.
What's provisioning like? I'm going to get a sensor and install it somewhere. What do I do when I flip the switch to turn it on? What happens at that point? Do I have to call you and say I've got a device ID, IMU, whatever numbers, and then?
I haven't got that far yet. We're going to have a call tomorrow, and I'll find out about that. We're working with a company here down the street that wants to talk about some details like that. So that's one of the things I'll get into. I've been with the company 2 months, and I'm a technologist, but not at that level yet. I will get there. If you get a chance, there is a 93-page tech overview that came out, and it describes the history since 2008 of what they went through when they had the theories, they put it in the field, it didn't work sometimes, and what they had to do to make it work to get to the commercialized product they have today. So if you're into that, you'll really love it. If you're not, it's a great way to put you to sleep. So it's on my link out there as well. Yes?
Are you offering any incentives for early adopters? Do you have an SDK?
We have SDKs, and right now they are $150 a piece for those. I'd love to give them away because I want to seed you guys. I want to give you guys the stuff, but it's not my choice right now. We can work on that. See, but it's not up to me. But we've got a lot of people that are trying to interface those SDKs into their sensors and put it into devices that they want to put out in the field. So
Tell your people we have a whole room full of
I know.
Tinkerers. We like to play.
Yeah. So I'll work on that. We have a call tomorrow, so I'll tell them we have a great receptive audience tonight, and that you guys want SDKs with the development kits. So that's what I can do.
Thank you.
All right, Graeme, let me turn it over to you.
Okay, good evening. I'm Graeme Cloughley from Information Xchange. And I'm just looking around the room here, and I'm not seeing many European Union flags on the ceiling here. So if I get chatting to you at the end of the night, just don't mention the Scottish referendum or Brexit or anything else you want to talk about. Let's just talk about the technology.
Can you talk about Texit?
Good one. Haven't heard that before. Okay, so who are we? We are a small startup here in Austin. We've been going for a number of years now. We have a small core team of senior software people. My good colleague Michael Hathaway couldn't make it this evening, unfortunately, because of a family emergency. But no doubt Michael will be up again in front of one of the IoT groups here in Austin. He likes to do the regular speaking circuit, and especially in regard to security, in respect to the industrial internet. So we are an industrial internet company. We make the distinction here between Internet of Things and industrial internet because we're not really going after the consumer market. We are going after stranded data that exists in a whole variety of different businesses, a whole variety of different companies that is out there, but it's not being used in any particular form right now. Ed touched on that slightly about SAP and how they have some tools there, some tooling in their system to actually help them deal with that. What we're doing is basically getting all of that data from devices that typically don't talk IP, pulling that data from them, making it very easy to push that data up into a private cloud or keep it on premise, or for that matter, out to the normal corporate clouds like Amazon Web Services, AWS. So what we provide is a subscription-based network service that allows you to basically take data from a variety of different devices, whether it's electric meters, water meters, or any other devices. There's not really any restriction. We're building the libraries for devices as we go. Something that's kind of different from the approach that we are taking is we're not viewing the Internet of Things or the industrial internet from the corporate enterprise viewpoint. We are very much talking about a lightweight application interface to your data that can basically run on a small agent device and basically collate the information, be it wireless data, be it discrete information from a Modbus device, or for that matter, BACnet. So that's in contrast to some of the other players in the market who have large enterprise type systems, which are very complex, very many software layers to go through. Our system is very lightweight, it's not rocket science, but it does serve a very valuable need for a lot of these legacy devices out there. So why is that useful? Well, we have.
That's done.
Very good. Oh, you can hear me. Well,
We can hear you.
okay. So I just keep talking.
Story time.
It's story time. So what we have is we have this flexible platform that allows us to tailor it for different types of industries. So if you were looking at transportation or you were looking at utility markets, we can customize our platform because it's very lightweight. We can tailor it for individual customer or corporate needs. And we've already done that with some of our pilots. We're already piloted with a large corporate carrier in their network operations center. And that's been a very successful deployment. So we can tailor this very easily. And we typically work with the end users of the system, and we've also worked with the analytics people who are actually going to process the data, maybe in their business units. So integrating legacy systems, well, what does that really involve? It really revolves around having the ability to acquire the data from something like a building automation system, and acquire that data, pull it into an appropriate piece of software running on an agent PC. Great. Hello? Hello? Good. So we have this ability to bring in a number of different protocols, be it BACnet, be it Modbus. These are the ones that we have a main experience right now. But we're trying to build it, as I mentioned, the device library that supports a number of different varied protocols. And that includes any of the devices that are using any of the new radio technologies, perhaps from Ed and some of the other players in the market. So,
It's coming.
So does your software sit on the end node, the sensor node?
yes, it can sit on the end nodes. One of the distinctions that I'll make clear in the slide here when it comes up is that a lot of our customer bases aren't very happy with the notion of their data actually going to the private cloud. In fact, our first pilot customer said the data doesn't leave the building. And that's how we basically started building our industrial IoT system, was say, how can we circumvent that such that we can provide a platform as a service, be able to charge people for different data packets and messaging through the interface, but also at the same time give respect to the security constraints that the IT department of that particular corporation has. And so that's really where we came from. And I wouldn't quite say that we are anti-cloud, but we're working with the end customer to find the best solution for where they're actually going to store their data and where they're going to analyze their data. And that could be a private cloud in some provider somewhere that has secure facilities. That's one option, and we're actually working with a vendor that's doing that right now. Or it could be behind the firewall, just within their own private cloud. So what we have here is, this is basically our subscription service that we have. Typically we have, at the top layer you have, well, let me start with the bottom there actually. Let's work our way up, going right through the interface with the radio at some point. So what we have is, we have this agent technology that can reside on a number of different platforms. It could be a small industrial PC, it could be an embedded format PC, it could be one of these micro PCs. It doesn't really matter as long as it's currently based on Linux, but it can be compiled down as well. So we basically use that to acquire data from various different sources, put that into the correct format that allows us to then push that data up to our cloud platform as a service. So you see at the bottom there it says different types of water meters or electric meters or sensors or legacy building automation systems such as Johnson Control Systems or Siemens Systems. That's actually one of our main customers in our pilot, is actually using a Siemens system. So you may notice actually, just before I finish off with the agent there is actually an analytics component, and actually we're getting a lot more interest in doing analytics at the edge, where you may have a lot of, for example, Ed gives a good example there about vibration data. Perhaps you might not want to stream all that vibration data across your wireless link, and so maybe you want to do some of that processing at the edge itself. So that's another part of our platform which we're exposing as a microservice. So we're able to use the REST API and stream data to our platform as a service offering. In this particular example, we're actually using a public cloud, and what we have on our cloud is an administration platform that allows basically customers to tailor their data to specific individuals. And this is really the security component that makes us different, is its ability to restrict data I/O points down to the user level. So for instance, there may be a number of users, they may be software developers, they may be people that are looking at a visualization across the company and are just using it for monitoring. The ability to actually look at different data points through the interface is done through our administration layer. And so we do this, we execute this particular approach by using something called device maps for Modbus devices. And if we're using or talking to any building automation systems, we typically use their discovery methods to actually find out what devices are on the network. And by doing that, what the agent can do is to basically report back to our cloud platform on what's actually out there. We then go through our security policy with the customer, and we can basically abstract what data points actually have a user has particular access to. And then to enable that, what we do is we basically create a template that is very specific to that particular individual, and only that device will only run with that template restricted to that user. That's then sent down to our agent, and our agent is smart enough to interpret that and also see that there's any restrictions or restrictions of change on particular groupings of I/O points. So in effect, what we have done is separate data and also the control path of these to different approaches. So again, somebody mentioned REST APIs over here. That's how we're presenting all of our data to the upper layers of the IoT stack. We, from the very outset of designing our platform, we made it mandated that all of the devices would basically speak through a REST interface, and it would be a very flat format. The approach was that we were not going to wait for standards and wait for different protocols. Let's just use the lowest common denominator for input into databases, and then just basically pull that data from the agent. So all of the data that comes from the agent is just JSON data. It's JSON format.
Is the agent a specific point of failure, or you have got multiple
Sorry, could you repeat that?
Is the
Sure.
agent is a single point of failure, or does got a backup agent?
There can be backup agents. Right now, we haven't encountered any situations where we've actually needed that. One distinction, and that's a good point actually, is that we are a monitoring system. We are not trying to replace a building automation system. The Johnson Controls system or the Siemens system, that will still operate as normally. But instead of having the stranded data that you have with that system, we're pulling that and then exposing it to the appropriate people that are using our service. Good question, thank you.
So the REST API and the data that is getting streamed, do you all have a standard for yourself when you're?
No, well, yes and no. The standard is it's standard data format. It's in JSON format, and so if you can parse JSON, you're there. It's not as nasty as XML or any of those other data formats. And so you can easily import it into a variety of different tools, whatever tool you're using for analytics or for that matter, you're wanting to use for your web application. So that's where we're starting from. You might ask yourself, well, what about the different water meters? How do we talk to them? How do we talk to the different Modbus meters that are out there? They have different register maps. How do we deal with that? Well, that's the thing that we're going to rely on the customer base to basically fill out. And we're obviously going to do that for our customers, but we're basically going to provide open standards to do that and make those available to the user base. So if you had a particular type of AccuEnergy meter, for example, that might be supported on Modbus, we would give you the register maps for that, and you'd be able to plug it in easily, and you wouldn't have to do a lot more effort there. What we are working on is an automated application layer that will allow you to basically create these driver or device maps on the fly by just being asked a number of different questions, and also having the specifications of the water meter, or for that matter the electric meter. So that's something that's in our roadmap right now. It's not right in the platform as we speak. So I could finish by just saying that as far as having the database of the acquired points and being able to access the data that's currently that currently represents your industrial IoT application, we then have a unified service layer that can then feed that different data using the security policy that we've already set up for the I/O points. We can then reflect that back in the application program interface for the applications. So there's different groups within the organization that all want to see the same data. We can make that available through the unified service layer that we have, and that can be then plugged into dashboards or mobile apps or whatever you fancy. So in kind of summary, so we have a unified service layer that you can basically plug into that will allow you to basically customize the different data subscriptions for different types of industry markets, and for also, with that matter, who is actually going to be using or looking at the data. So it's very specific to the security policy that's being implemented by that particular company. We don't define that for the company itself. We rely on their current security policy and work within those realms to tackle cybersecurity issues. And as far as accessing the data, you don't see any of the nuances with industrial automation protocols. That's all hidden from you. It's just a REST API, and it's data coming as a JSON formatted format. And that's very, as you know, it's probably very easy to work with. As far as different options for the actual system, we've started on an on-premise system, and that was our pilot project. We're now looking towards more cloud-based systems, or private cloud-based systems, where the actual hosting entity has a secure facility, and it can be guaranteed to be secure 365 days, 24 hours a day. And again, the notion about security policy enforcement, the encryption and the access controls and privacy, as you would have with any transaction that you're having within your organization. obviously what we have is this policy control via the device templates, and only the people that are actually going to access those particular data points have the ability to do so. The system you can't basically hack the data unless you have access via those templates. So that's it in a more functional format. We have a number of subscribers, and we have our data source at the top. We have our microservices that are exposed down below via our agent. And then we have also the administration and data management services that are typically on a web platform that the administrator, it might be a building facilities manager, might look at that and use the web interface there. What I haven't really talked about is the microservices layer down at the bottom. And that microservices layer is becoming very popular way of passing data between different elements of the IoT stack. And we're coming across a lot of requests about analytics in regard to, can you just format that data in a certain way, or can you look at last week's data, summarize that data and then pass it up to us. So that notion about being able to plug into our system, we have this microservices approach, and you can basically make requests from our microservices to get the data out at that layer. So here's, to tie back here to Ingenu, which is with regard to the radio being the connectivity piece, as Ed has called it. We are, when you look at smart city use case applications, one thing that we like to distinguish is we don't think about monolithic municipalities within Austin. We think more about private entities that basically are wanting to exchange data. I guess it's a worldview thing, but if you look at how data is stranded, not only within one organization, but across organizations or different companies, there's a problem there. And so we're taking the approach of, we know that this is a problem, we know there's going to be security issues, we know there's going to be IT issues, and we just work with it. So when we're dealing with a smart city, obviously this is going to come to a head where you have different vendors that either do or do not want to share data, and the ones that do, they have to work together by obviously agreeing to certain formats and certain standard protocols, hopefully using IP, or for that matter, standards using Ed's network. So in the smart city approach, we also have connected buildings and utilities at the bottom there. It's seen as more of groupings of different applications, such as public safety or emergency management or traffic. And in those particular applications, that's where the wireless networks really come to the fore, in their ability to basically reach out to areas where typically there wouldn't have been a way to actually access the data. And again, tying back to the idea of stranded data, we're trying to get that stranded data so that people can use it and make decisions about it. Okay, well that's all I had basically with regard to Information Exchange. Have another question?
Could you give a couple of examples of applications that are currently using your platform?
Sure. I have one application which is very tailored to a certain audience. So this is typically, this could be a wireless M2M backend where we're in an exact situation where we're dealing with devices that may have certain ASICs in them from certain vendors. That are speaking through the M2M wireless network. Where we basically fit in is to provide the application service to supplement what companies like Ingenu have already. They're obviously handling the connectivity pieces and making sure that that information is available. What we're providing is a layer on top of that will allow that information then to be farmed out to the appropriate people that are subscribed to our service. And why is that important? Well, otherwise you're just starting with a raw REST API interface, and then at that point you're building a system. We've done this already. We have deployed systems that are using this as a service, and obviously the subscription cost for that is somewhat in line with where Ed is with his model. And that's also flexible. We're a startup. So this would be a typical application there. As soon as it's obviously in the cloud, the data might be behind some firewall somewhere. Once it's actually stored, how do you manage that data? Who has access to it? Which high-level applications developers or facilities managers or whoever's looking at the data, how do they access that? And they can use our platform via the policy controls to actually do that. That would lend itself to an M2M network. That makes sense.
So you have your own developers then that would custom design solutions for people who need them, right?
Yes, so we are not in the application space. We do not develop any of the high-level applications. We are basically, as the company suggests, we are the Information Xchange part. We are getting the data, appropriately formatting that data, allowing for the security and policy control, and then we're handing that off to our partners that basically go ahead and write applications around that. So we have analytics partners, we also have web developers and mobile developers. It really depends on the vertical. Actually, transportation, utilities, they all have their own niche applications that they need to provide services for. And in addition to things like transportation and building automation system monitoring, also in healthcare, that's another area which I haven't really dived into, but it's the same issue. We can look at particular devices that are connected to a hospital ward, for instance, and we can use the same kind of policy control approach to pull that data and make sure only certain developers or certain people can actually access that data for their applications. Any other questions? .NET guy.
You mentioned baseline analytics at the device itself, but then followed up by saying you're not an application. So is that baseline analytics basically just a filter on the data that gets transferred to begin with?
No, it could be actual processing. It could be temporal storage of that data. So say for instance it's looking at a week's worth of data. You may be doing some fancy processing on it. It really is application specific. If you're in a building and you're just looking at slow-moving temperatures, you're not going to need any high-power analytics. Whereas if you're doing vibration monitoring, you may have masses of data at the endpoint, and you basically want to decimate that down to something that's more usable, and then pass it up to your main application. So yes, there's ability to temporarily store the data, but it's really based on your application. But we're making a point of that because a lot of the IoT platforms are forgetting that part, is that you can do processing at the edge, and what with not only hardware, well, you can also use software in a small industrial PC as well.
Who's your dream customer, and what is the magic use case that you see there?
Well, the magic use case is continued subscriptions of our data. But I guess the end point for a lot of customers is, why are they not going out and buying these expensive IoT enterprise systems? It's because they don't know what they have. There's a whole bunch of siloed data out there that hasn't been acquired. They've never seen the data before. And the only time a facilities manager for a particular building or series of buildings knows about it is when alarms are going off from the industrial automation system. But they can't do anything with that data. And that's how we basically started. And so our ideal customer, in effect, is we are going to basically allow people to understand their data to the extent that they'll be able to start deploying new sensors and new devices to acquire more data for them. And that could be particularly useful if you're looking at building automation systems, especially if you're looking at cost control and temperature and how buildings are heated during the winter and air conditioning in the summer. It doesn't seem like much, but if you have sensors all over the building, and of course new builds will have some of that, but what about the old builds? You know, the cycle time of a building might be 20 years. The cycle time of an industrial automation system might be 10 years. What about all that information that's not being acquired? And that's where we're trying to fill the gap, is basically get that legacy data, get it out, allow analysts to look at it, allow facilities managers to look at that data and say, we've got a problem here, we need to put some more low power wireless sensors in there, or for that matter, put them out in the field to find out what they've done with their rail car. And we actually have talked to people about that.
It's matter if you don't know what you don't know.
That's right, that's right. And you know, as far as applications go, we're open to different applications that are coming in the door, and you know, it's getting to that point where we're saying, okay, we've got to choose a vertical here to basically flesh out the platform.
So you're focused on the data itself. You
Yes.
provide the endpoint for the edge devices to communicate in,
Yes.
and the endpoint for the applications to
That's
communicate
right.
with the data that was collected.
That's right.
You don't provide the application side or the edge side, is that right?
That's right.
Do you
So
have partners, I know you said you had partners doing the application side,
Mhm.
or you have companies that come to you to get access to data. Probably they're producing whatever it is in the edge as well.
Yes.
So, in other words, they're monitoring air conditioning systems for
Right.
companies which they've retrofitted
Right.
sensors into their buildings.
Right. Yeah.
Do you have lots of partners that do that part of the work, the edge side?
Well, they are almost, you know, they're very essential. We're focusing specifically on the data acquisition and the exchange part of the information, but to actually acquire the IP data and do translations between industrial protocols, you know, there's a variety of different vendors out there that already have solved that problem. We're not competing against them. We're leveraging their solutions and saying, you know, to a customer, how can we get that data into the system? Or we need to basically have a protocol driver that's appropriate for our platform that works for the particular application in question.
Do you think there's an opportunity for businesses to develop, you know, working with an organization like yours, creating those edge sensors?
Well, most of the newer devices are going to talk IP off the bat. And I guess that's a subtle distinction. Is for the legacy devices that are out there that are non-IP based. I mean, that's basically the dividing line. It's like you're going to be able to see that data once it's on an IP network. Yeah. And so, you know, we've seen examples where we have, you know, thermostats or in buildings that are, you know, 10, 15 years old, and they're incredibly expensive to replace. And they're not even digital, they're not even on the network. And that's a challenge. But we can help by putting appropriate systems in place to acquire that data and get it on the IP network and let the people see the data, sometimes for the first time.
Is there already solutions for, say, a thermostat? If you have an old, you know, thermostat, you mentioned.
Well, that's part of the driver library effort of the ecosystem, is to basically find out, you know, what people are using out there, and have it such that there's device maps, particularly for things like Modbus, and make those available to our customer base so that they can quickly and easily get to their data. That's our MO really, is get the data, make sense of it, and continue to subscribe. That's a good question. Any more? Okay, well, thanks very much. That was just a very short introduction to our company, and hopefully next time, when Michael's available, he can come in and talk a wee bit more about some of the cybersecurity implications and how that might affect industrial automation applications. Thank you.